Okay, so the first thing that I need to clarify is the difference between the brackets over here and the parentheses. So I believe that the impression that um, she gave was that basically um, parentheses were just used for infinity. That's not true. Now, they are always used for infinity, and there's a reason for that. But ultimately, here's the difference. So the parentheses, right, these are what's considered to be an open interval, right? Writing it very quickly. And these are considered to be a closed interval. And you get the point. So what does that mean? That means that the open intervals are constantly approaching but never reaching, right? So if you were to write the interval, let's see, 1 to 3, right? The parentheses and the 3 are connected, right? I'll even dye them red. So, right, these are connected. They're the same, right? And the 1 and the bracket are connected. Now, what this means is that the interval is, let's say on a number line, constantly approaching 3, right? We got 1, 2, and 3. Then our interval is going to be like this. It's very close to the 3, but it never actually quite touches it, right? So that's our interval, right? You see, it touches the 1, but it doesn't quite touch the 3. It's kind of like a tangent line, which we learned about last year, right? So let's say this orange line here is the tangent line, right? And then this green line is f of x, right? You see how it gets very close, and it constantly is approaching the orange tangent line, but it never quite reaches it. That's what the tangent line is, and that is, in principle, what an open interval is. It is constantly approaching 3, x equals 3, but it never quite reaches, right? So it's as close as you can get without reaching it. Now, the reason that infinity is always at an open interval is because infinity is a concept. It's not a real number. So when infinity is written like that, right, you're not actually going to ever reach infinity because it doesn't really exist. It's a concept. So when you write infinity, you write it with an open interval because you're getting as close as you possibly can to infinity, right? Going on and on and on forever, but you're never going to reach it. And so that's why it's an open interval. In this lesson particularly, the difference is in the greater than, the less than, and for the closed intervals, the greater than or equal to, and the less than and equal to. So the best way to express that, right, let's put a closed interval back up here. Or sorry, an open interval. We'll start with that. So the open interval, let's go with 1 to 5. Right. Another way of writing 1 to 5 is 5 is less than x, which is less than 1. Now, what does that mean? That means that x can equal pretty much anything between 2 and 4. Pretty much. You know, technically speaking, it could be 1.1 to 4.9. But, you know, in between. So it's in between these numbers, but it doesn't actually include these. X does not equal 5. X does not equal 1. So that is why this is important for this lesson. Now, a closed interval, we'll do 1 to 5 again. So x, when written like this, equals any number between 1 and 5. right? So 1, 2, 3, 4, 5, any decimals in between. That's what that's saying in this interval. And that is what a closed interval is. So a closed interval can be written, and this, you probably should write this down. This is important, but these are what an open interval looks like. This is what a closed interval looks like. So on a graph, let's start with a number line. Let's go for an open interval. Let's graph -1 to infinity. Very open interval. The way you'd write that is, because it's an open interval, right, you would write it like this. Right? You'd write it with an open circle. Right? If it were a closed interval, you would write it with a filled-in dot like that. Now we learned this part in Algebra 1 as x is greater than -1. Now you write it like that with the open circle to indicate that it does not include -1. If we were to write a closed interval, right, being x is greater than or equal to -1, then this dot would be filled in. And that filling in of the dot means that it includes -1. So x could include -1 or any number between -1 and infinity. Okay, so let's go back to the worksheet real quick. So we're solving nonlinear inequalities, meaning that this is not a straight line. That's all that means. Now, step 1 on the worksheet says solve f of x equals 0. What that means is that basically, well, that's a little bit redundant to say. So basically what it means is solve for the zeros of the function f of x, which is what this is. That is f of x. And it is saying that these combined create a polynomial that is greater than 0. Right? And it wants to know in what cases is that true. Now, it says to create a sign chart. I think it's a little bit stupid to start with a sign chart without properly visualizing this. So let's get another number line out. Right? The first thing we should establish is what are the zeros, right? The zeros of these numbers here are 3, -1, and 4, because remember we set this equal to 0. X minus 3 equals 0 means x equals 3, and so on. So on a number line, right, and let's actually do a full graph just to, we're just doing that to visualize, right? So we've got -1, 2, 3, 4, 1, 2, 3, 4, and I'm not actually going to put anything here because it's not important right now. So we've got -1, -2, -3, -4, and we have 1, 2, 3, 4. Right, so where are our zeros? Our zeros are at 3 over here. In fact, I'm actually going to use a different color so that it stands out. We're going to use this color. Very standouty. 3, -1, and that's supposed to be a -4. I don't know why I didn't write that. I'm sorry. But -4. Now, we have our zeros. Now, judging by what the information that's given here, right, you can tell that the graph is going to end up looking something like this. Right? How do I know that? Well, we can see that there are 1, 2, 3 x's, meaning that it has a degree of 3, right? X cubed is going to be the leading term of this polynomial when it is put together, right? And that's all you need to know for this, right? I mean, there's another thing, and that's the leading coefficient is 1 for all of these, meaning that when you combine all of these together, you're not going to get something like -4x cubed, because there's nothing there, right? It's just going to be 1, because this is the same thing as plus 1x cubed. right? If it was negative, then it would be going more like this, right? But it's not. So x cubed, the degree is odd, right? Because 3 is an odd number. That means that it looks more like this strange shape as opposed to a parabola of any sort, right? That's why it looks like this. And so we can see the zeros because they're basically given. So you know what the end behavior looks like. Now, it wants to know, the answer is basically what interval values, or what intervals is f of x greater than 0. Now, f of x, that's the y-coordinate. So where is this graph, the y-coordinate of this graph, greater than 0? Or what x values is the graph above x equals 0? Right? Well, I mean, you can see visually here, right? Here and here and beyond, right? It's all above 0. So, right, you can see these intervals, right? Now, because of this greater than sign, really, I probably shouldn't have filled these in, right? Now, this doesn't really apply to this sort of a situation, but basically, and this graph is not at all drawn accurately, drawn to scale, right? So this line, technically speaking, never quite reaches -4, never quite reaches -1, and never quite reaches 3. It gets very, very close, but it doesn't actually approach it when it crosses the x-axis. So technically speaking, the line doesn't actually cross at -4, but it crosses close. So you could see the intervals here where it is greater than. It's going to be very close to, at an open interval, between -4 and -1, open interval, because it doesn't actually reach it, because this is not a greater than or equal to sign. It's just greater than. Now, over here, you can see that it does a similar thing, right? It comes out at 3, right? But it doesn't actually at 3. It approaches 3, but it doesn't actually quite reach it because of, again, the greater than sign, meaning that this creates another open interval from 3 to what is assumed to be infinity based on this arrow and based on the information given. So that is the graphical way to solve this inequality, and I think that's really how it should have been taught first before, trying to start with the sign chart. But now that you understand literally what it is saying, or graphically what it's saying, now I think it's more fair to try and start on the sign chart, which is another way of finding that answer without a graph provided. Now, because sometimes these equations are going to be a lot more complicated than just simply simplifying to x cubed with a positive leading coefficient of 1, right, and a degree of 3. It's going to get more complicated than that, right? You're going to get crazy numbers, and it's not going to be that simple. You're going to have significantly more zeros than just 3. So doing this sort of chart shortcut is it's going to be helpful. So first off, let's write down these x values that are given here on the side like this to form a sign chart. Now, a sign chart doesn't refer to like cosine, sine, tangent, that sort of stuff. It literally just refers to positive or negative. That's it. So in this chart, right, you're going to be given a few things. You have to work with the zeros, which are actually written in opposite order. It is imperative that they are written in ascending order, like this. Why does that matter? Well, it's the same thing as the number line, right? You know, you can't put a positive number on the left side. That's not how it works. On a number line, this is the order it would be written in. So it needs to be written the same on the sign chart. Now, these areas over here are actually the intervals that you want to be focusing on. Right? So when I write the graph out, it's actually going to be more like this. Right? Because we're really focusing on the intervals in between. So the interval here would be negative infinity is less than x, which is less than negative 4, right? Or another way of writing that, and I'll write that on the bottom here, right? But a way of writing that would just be negative, that's an 8, negative infinity, comma, negative 4, open interval, because it's a greater than, not a greater than or equal to. That's that interval. This interval is going to be all the numbers in between negative 4 and negative 1. This interval is going to be all the numbers between negative 1 and 3. And this interval is going to be all the numbers between 3 and infinity. Now we already know the answer for which of those 4 intervals, which it wants us to identify. By doing this, we've already identified the 4 intervals. We want to do that again, but we need to decide which one of these intervals is f of x greater than 0. We already did that graphically, but we're going to do it numerically with this chart. Okay, now I wrote the intervals like this so that it would be, well, smaller, more compact, but really the intervals should probably be written like this, right? Just know these say the same thing. Infinity is less than negative 4. Right, and why did I do that? Well, this is the interval that we're testing the negativity or positivity of, because we're going to want to write a minus sign or a positive or a plus sign in all of these squares, actually. That way we can determine which one of these is going to be greater than 0, because again, any number greater than 0 is positive. So between these numbers, any number between negative infinity and negative 4. That could be negative 5, that could be negative 79.8. It doesn't matter. When you insert an x value in this range, which is between negative infinity and negative 4, we'll go with negative 5, right? Negative 5 minus 3 is negative 8. Any number that you put in this interval for x in this problem is going to be negative. Now, try the same interval, but a different equation. So any x value that is in between negative infinity and negative 4, put in this equation, right? We'll go with negative 5 again, right? Negative 5 plus 1 is negative 4. So again, it's negative. Now our final one is x plus 4. So any number in between negative infinity and negative 4 for this problem, just for funsies, let's go with a different number, negative 7. Right, I still want to keep it simple so that this is an easy thing to do. But negative 7 plus 4 is negative 3. Again, a negative number. So for this interval, any value of x in this interval for these zeros is going to be negative. Right, and what does that mean? That means that it's not greater than 0, because a negative number is not greater than 0. That means that you can forget about this interval, because it does not satisfy the equation. F of x is not greater than 0 in this interval. Let's look at the next interval. Negative 4 to negative 1. This means any number in between negative 4 to negative 1. We'll do whole numbers because it's easier. Negative 2 or negative 3, pretty much. So let's stick with negative 2. If we insert negative 2 in for x here, that's going to make a negative 5. That's negative. Right? Over here, if we inserted a negative 2 plus 1 is negative 1. So that's still negative, right? And then x plus 4, if we insert negative 2 in there, that is a positive 2, meaning that's a plus. Which means that in this interval, overall, it is positive. Now, why is that when there are more negatives than positives? It's like multiplication, right? If you multiply, and let's just put 1 in here for funsies, right? Negative 1, and positive 1 together, all of that is going to equal 1 because these two negatives not cross, but just regular cancel out. And then, positive times positive, right? Because we can't have double negatives, right? Literally, what is happening here is it's saying that at this 0, it is negative. At this 0, it's negative, but at this one, it's positive, right? So this is this is saying it's a negative expression. This is a negative expression, but this is a positive one. And because of the parentheses being written like this, you multiply all of these together, right? So it really doesn't matter what this is, as long as it's in this interval. Think of it like negative x times negative x times positive x, right? You're going to get positive x cubed. But the point, the cubed part isn't important. The point is this is positive, right? And it's positive because the double negative and then the positive, when you multiply them together, they end up positive. That was a very long explanation, but basically what that's saying is that this interval is good. Now let's do the next one. Negative 1 to 3. That leaves 0, 1, and 2, pretty much, in the whole numbers. All right, so let's pick 1. That's a pretty simple one. 1 minus 3 is negative 2. That is negative. 1 plus 1 is 2. That's positive. And then 1 plus 4 is 5. That's positive. Now, this is predominantly positive, but again, if we multiply these together, right, a positive times a positive is a positive, and then that positive times a negative is a negative. So this is overall negative. That means that this interval does not fulfill f of x being greater than 0. It's not. Right, now let's do the final one. 3 to infinity. That's any number between 3 and infinity. 4, 5, 6, 7, 8, 99, whatever. So let's do 4. 4 minus 3 is 1. That's positive. 4 plus 1 is 5. That's positive. 4 plus 4 is 8. That's positive. All of these multiply together make a positive number, meaning that this interval also fulfills the f of x being greater than 0. Now, how do you write that? The way to write the answer is going to be, well, there are a couple ways to write it. It asks for interval notation. That means this, right? And then you're going to write a U, that means union. That is basically just a fancy comma in terms of how it acts. Now, these need to be in parentheses because we're not touching any of these numbers in these intervals. Just a quick reminder, but that is the answer, and this is the sign chart. Okay, let's try example 5 because it is a little bit different. So x plus 2 squared, let's write it out all the way, right? That's x plus 2 times x plus 2 times x minus 5. Now, it wants to know for what intervals is f of x now going to be less than or equal to 0. This means that it includes the zeros, and it is also going to be negative. Basically, when is f of x negative? And 0. So fundamentally, that isn't changing the process. The only thing that's changing is for the intervals, we're going to be using the brackets, or closed intervals now, instead of the parentheses. But fundamentally, it's the same otherwise. So let's get started. So we can graph this out really quickly, and I will do that very quickly. Okay, so I drew the graph here real quick. Now, if we were to simplify this out, you would find that your leading term would be 1x cubed. Now, you could just see that, right? Because the first number isn't going to be the confusing one. It's everything in between. The first and the last number you can see just from the fully factored form. So you've got x cubed as the leading term, right? The leading coefficient is a positive 1. That means that it's going to end up on the end behavior is going to end up like that. And because the degree is odd, right, the rest of it is going to end up like this, right, as opposed to a parabola, which would be if it was x squared, or x to the fourth, or x to the sixth, etc. So that would be the end result. Now, these are the zeros, -2 and 5, but there are 2 here, right, because this term has a multiplicity of 2. What does that mean? It means that basically at -2 it functions as a tangent. So the graph of f of x is going to approach -2, but it's not actually going to cross there. It's going to boop it, but it's not actually going to cross there. Now, I'm not saying it's going to come back like this. It might, but who's to say? But it will cross at at +5, because that's got a multiplicity of 1. Right, so it just touches -2, doesn't cross over, and then it does at 5. Right? If that weren't the case, then it actually would end up being a parabola. So this is very important to know. Now, this one does look a little bit drunk, but that's just me. It's not supposed to look like that. So yeah, now you could just see, judging from this graph, when is f of x less than or equal to 0? Well, pretty much from this arrow going to -infinity. Now that is an open interval because we'll never reach that. Pretty much to 5, right? But since we know, because it's less than or equal to, right, it's 5 exactly, right? So it's a closed interval at 5. It's not approaching 5, it is at 5. And we only know that because of this sign right here. So it matters. So pretty much that is the interval, right? This is the answer right there. That is the only time that f of x is less than or equal to 0. Okay, now let's try that using the table, the sign chart. So first, let's write down our zeros. Right now, because this appears twice, I'm not going to write it twice because, when you do the math, it's going to end up the same, right? And the same with the zeros, right? This 0 is -2, right? We can see why. Okay, to save time, I already wrote the table out for you and everything. So for this first interval, right, between -infinity and -2, right, just pick any number between -infinity and -2. I'm going to go with -3. It's a simple number. Although, actually, you know what? Because it's a less than or equal to, we can also pick -2 itself. Now, -infinity, that's still an open interval because we're never going to reach -infinity. But -2 is a closed interval because of the less than or equal to. We're obviously going to reach 2 because, as we saw in the graph earlier, it does, in fact, actually touch the point -2, 0. So at -2, right, -2 plus 2, that's going to equal 0. Now, that's a new thing. Now, we are looking for intervals that are less than or equal to 0. It equals 0, so it's fine. Now, say we had picked -3. -3 plus 2 is -1, so we would have written negative. It doesn't matter which one for this situation, right? Let's say that this wasn't a less than or equal to. It was just a less than, and it equaled 0. That would not be good. That would mean automatically that the whole thing would be out. But it's less than or equal to. So a 0 is fine, right? But as we also showed, there is a negative as well. So I'm going to write both in. It doesn't matter in this situation. Now for the next interval, we're going to do negative 2 again. Negative 2 plus 5 is 3, which is positive. Say we picked negative 3. That would have been negative 3 plus 5 is 2. So again, positive. So let's reason this out, right? So this first box here, that is basically the same as 0x, because we're treating that kind of like a sign, right? And then that times positive x, or just x, that's going to equal 0, which is fine, according to this. It fulfills f of x requirement of being less than or equal to 0. So that's completely okay, right? But if we had picked the negative, right, then it would just be as simple as negative x times x being negative. Well, it's going to be negative, right? It'll be negative x squared, but the negative's the important part. So combining all that together means that this interval is, it does fill the inequality of f of x being less than or equal to 0. Let's do the next one. So negative 2 to 5, right, it can include negative 2 and 5. Let's go with 5. 5 plus 2 is 7. That's positive. 5 plus 5 is 10. Again, that's positive, but wait. So let's go back. Let's pick negative 2. Negative 2 plus 2, again, is 0. Negative 2 plus 5 is 3, which is positive. So again, we reach a very similar situation where we either have a 0 or a positive. Okay, so this 0 actually trumps the positive. So, right, because anything times 0 is 0, right? So in all cases, right, this 0 times the negative, 0 times negative 1 is still 0. So the 0 really trumps that negative as well over there, and I didn't write that, and I should have. But, yeah, so that ultimately is going to end up equaling 0. This also is going to ultimately end up equaling 0. So this interval is good as well. Now let's do this final interval here. 5 to infinity. Any number between 5 and including 5. Well, let's start with 5 again. 5 plus 2 is 7. That's positive. 5 plus 5 is 10. That's positive. Okay. And, you know, any number, obviously, greater than 5 when you add 2 or 5 is going to end up being positive. But that does not fulfill the equality of f of x being less than or equal to 0. Right? So that means that this interval is no good, but that means that these two are. Now, how would we write this? You might be tempted to say that you would just write negative infinity to negative 2, and then, union negative 2 to 5. This is not right, so don't write it down. But the reason that this is wrong is because this includes the negative 2. And this includes the negative 2. Well, okay, so technically speaking, it's not wrong. I don't think that the AP test, if you wrote that, I mean, there's a chance they might say it's okay, but I suspect they probably won't, because this, I mean, this is kind of the same thing as writing x squared minus 9 for a factored polynomial. That's not fully factored, right? You can split this still to be x plus 3 times the quantity x minus 3, right? This is the factored. This is not finished. So I suspect that on the AP exam, it's going to be a similar case with this, where you are going to want to simplify that down to negative infinity to 5, like that. And this ultimately is the correct answer. And you'll see that is what matched up with our graphical solution earlier.